After today's lesson, you will be able to identify absolute value functions given a table of values, as well as identifying the rate of change for an absolute value function given a table of values. Due to a drought, the canal from a reservoir is opened so that the reservoir is lowered by 20 feet per day for 5 days to meet the irrigation needs of farmers. After this, the canal is closed and water is directed from a river to raise the level back to its original level, 250 feet, at the same 20 feet change per day. So let's highlight some key information. We see the word lowered here in 20 feet per day. That would be a rate going on for 5 days. We have an original level of 250 feet, and then it's going back up at 20 feet per day again. I'm going to zoom in on our table to fill in some of this key information. We are told that the original level is 250 feet. That means on day 0, we have 250 feet of water. That is also called our initial value. I'm going to write that here. Make a note of that just to remind yourselves of this vocabulary that we started the year with. And then each day, if I pan back down, each day the water is lowered by 20 feet per day. And so that tells us that at day 1, I'm going to go down by 20 feet, so this is going to be 230 feet. At day 2, I'm going to be at 210 feet because I'm going to decrease again by 20 feet each day. This pattern is going to continue for 5 days, and then the river is diverted to this reservoir, and it's going to go back up. So we're going to keep decreasing for 5 days. So to day 5, we are going to keep decreasing by 20 for each of those 5 days. And then after that, we are going to increase by the same rate until it goes back up. So we're going to go increasing by 20. Fill in the rest of the table to match this scenario. And you'll see here, so this is decreasing by 20 and increasing by 20 is our change in Y. And we haven't written out what our change in X is, but what do you see happening for each of these days? Hopefully you see that the days are increasing by 1 all the way down our table. And I'm just going to do this to show each one of those is increasing by 1. Before we talk about rate of change, we're going to look at how this will look on a graph. So you can see I've labeled my axes. My x-axis is the number of days, and I just want one box for each day. That's my x. My vertical axis is my y-axis, and that's the depth of the water that I have over here. And because I needed to have at least 250 feet, I wanted to make sure all of that would fit in my scale. So every 5 boxes is 100, which means each individual box is 20. So to graph this, you can see that at 0 days, I'm at 250 feet. 0 days would be right along the y-axis. It's also called a y-intercept. So my first point would be right where my red cursor is at 250, because I'd be halfway between 200 and 300. And it's going to go, for each day, it's going to go down 20. So I'm going to keep going to the middle of these boxes. And I'm going to do that for 5 days. Because at 5 days, you can see I'm supposed to be at 150. 150 would be halfway between 100 and 200. That would be right here. Let's plot those on our graph. After that, at day 6, it's going back up. We're increasing by 20. So it's going to go back up to right here. And each day it's going to go up 20 until it reaches its maximum height again, or its original height of 250. So looking back at our table, let's start talking about what our rate of change is. And you can see that we have 2 different changes in Y. We have negative 20 and positive 20 as our change in Y, and our change of X's for the whole table remain positive 1. So we have 2 different rates of change. So we'll just recall that rate of change is always the change in y over the change in x. In this case, we are going to have negative 20 over 1, and we're going to have positive 20 over 1. So it's not linear, and you might recall from your notes at the beginning of the year that this is called absolute value, and an absolute value function graph has two different rates of change, and it's basically made up of two different lines. So we have two sections of constant rates of change. Between those two rates of change, I always like to draw a line to split and make that an arrow because it is pointing at the turning point. So this right here is the turning point of your graph. We're always going to circle that in our table, and that is called the vertex. What is different about the rate of change in this story? We have two rates of change, and they're what we call opposites. And that is just that it is positive and a negative 20 over 1. Let's talk about the key characteristics of an absolute value function, what we just graphed. First, I'd like to talk about the turning point, which is also called a vertex. We saw that between our changes, our rate of changes. That is our change in direction. What we see on either side of the turning points is that we have two constant rate of changes. And they are opposites, and that means there's a positive and negative component. We also see repeated numbers in our y values. Because of that turning point, they go up and down or down and up again. Which brings us to the last one, which is we see in our y values increasing and then decreasing. So it's increasing and then decreasing, or we might see it as decreasing and then increasing.